Okay, so we are starting with our machine learning techniques. The first one we are going to look at is classification. Okay, so whereas classification is basically you're grouping or putting up an object into a particular class. Okay, they can be that is in the case of classification, you will have the classes will be known to us, and given a data item, we will put them into say different classes. Say for example, we have say students who are eligible for placement, not eligible for placement, or based on data you can classify people as who have a disease or who do not have a disease, or web page is a phishing page or a not phishing page. So the classes are actually known to us, and given a particular data item, we have to put them into different known classes. That is what classification is, right? Okay. Now this is a formal definition. So given a database D is equal to T1, T2, etc. Tn are our tuples or our data items, and we have a set of known classes C1, C2, etc. Cm, and the classification problem is to define a mapping. So this mapping is what is the most important thing. Mapping, you have a mapping function from the data set D to the class. Okay, so each item called Ti has to be mapped from a data set to the class to which it belongs. Okay, so classes are, it varies from C1 to Cm and contains precisely the tuples that are mapped to it. And so a class Cj is a set of all tuples Ti such that when you apply the function f on Ti, you get the class. Okay, so this is a formal definition of classification, right? Now, data classification is actually a two-step process. Okay, so we have already come across the training phase and the test phase. I think those terminologies we have already discussed. So, data classification consists of a learning step or a training step where a classification model is constructed. Okay. The model generation phase or the learning phase or the training phase is there, and finally you have the classification phase where the model is used to predict the class labels for a given data item. So the first step is the learning step or the training phase, and here a classification algorithm builds the classifier by analyzing or learning from a training set made up of database tuples, and there so okay, so the training set. So there is a data set called the training set, which has a set of data as well as their associated class labels. So both of these values, tuples as well as their values, class labels, are known to us, and from this you build a using a classification algorithm, you build a model, or this mapping function is basically our model. Right. Now, tuple X is actually represented by an n-dimensional attribute vector x1, etc., x1, x2, etc., xn, depicting n measurements. So, we have already discussed this. Always a tuple or a data item is represented by an attribute vector. And for each tuple, a predefined class. Okay. In the case of classification, the class is predefined. This is as opposed to in the case of clustering, the classes are not predefined. Okay, and so in the data set, the class label has to be given. Okay, class label is the is one of the attributes. So we have the attribute vector as well as we have the predefined class for each of the data items. Okay, that is given to us. And the class label is generally discrete valued or categorical data, and tuples making up the training set, or the training tuples are randomly sampled from the database. Okay, you choose a set of randomly sampled items as a training set. Okay, given a data set B, a subset of it is taken as a training set, and the remaining you keep for testing later. That's called test set. Because the class label of each training tuple is provided, this step is also known as a supervised learning. Supervised learning is a term which we already have come across, and classification is a specific example of supervised learning. This is because that is supervised learning is training of the teacher. That is, in your data, you are already given that given a data item, what is the class it belongs to. Okay, that is given. So that is why we say it is a supervised learning method, and the learning algorithm actually finds the mapping function or the model. Okay, mapping is represented in the form of, okay, you can have, again, in the case of classification, you can have different methods or different algorithms to generate the models. They can be either in the form of classification rules or decision trees or what neural networks, or they can be different or support vector machines or any sort of, or a symbol, maybe a line equation or a mathematical formula can be our model. Okay, so this is our training phase. So we are given a data set which is labeled. Label means the classes are given. Okay, we have a data set, and out of which we choose a randomly sampled set as our training set, and using the training set we come up with a model, and then the second step is the model is used for classification. And to test the classifier, an independent set of tuples. That is, we said we have the original data set D, from which, let us say, 70% of the data is randomly sampled and used for our training, the model building phase, and the remaining 30% can be used as a test set. Okay, and then you can go for the accuracy of the classifier. Accuracy means that is the percentage of test tuples that are correctly classified with the classifier. That is a term called accuracy. There are also other measures to decide how good our model is, which we will come to discuss later. But accuracy means out of the total number of tuples, how many are correctly classified. Okay, this is one measure of how good our model is. Okay, so this is how formally classification is being defined. Okay, now we'll move on to decision trees. Okay, decision trees are actually one method of model building. Okay, and a decision tree is a flow chart like tree structure where each internal node, that is a non-leaf node, denotes a test on the attribute. Okay, so each of the internal node actually is actually a test on the attribute. That is, what is that is age, whether the result is youth or middle aged or a senior citizen. That is a test which happens at the internal node. And each branch represents an outcome of the test. Okay, here at the internal node we have got a test. Okay, and each branch actually represents one of the values or the outcome of the test, and each leaf node actually is the class. Okay, so if you look at this particular example, this is a tree. Here internal nodes are for testing. The leaf nodes represent the class to which the particular data item belongs, and each branch actually represents the possible um, what the possible outcomes of the test. So here in this example, this is a data set from which we have actually constructed this decision tree, and here what is given as age can have values youth or middle aged or senior, and income can be high, medium or low. Okay, and the data represent actually people who would like to buy computers from a store, all electronic store, and the person can be a student or not. He can have a credit rating, can be good, fair, excellent, and finally this is the actual class label. Okay, so from this data item, what we want the classifier to do is, for each item we want to build a model that will predict whether a particular person will buy a computer or not. Okay, that is a prediction we want. So from that, from this data, we build a tree, and at the top of the tree, we have got the best attribute is age. Age is one of the attributes, right? So we ask, what is the age of this particular person? So given I am giving my data to the model. Okay, this is our decision tree model, and I'm giving my data. So my age, they're asking for my age. So maybe I'm middle aged. So which means I will buy a computer. So that this is the class to which I belong. Now, if it is maybe one of you, okay, one of you, then age maybe belongs to youth. And the next question is, are you a student? If you are a student, you are more likely to buy a computer, right? So if you are young and if you are a student, then you are likely to be a computer. But if you are young and if you're not a student, you're not likely to buy a computer. So these are the different classes. The classes are either you buy a computer or you do not buy a computer. Okay. Now here you've got credit rating also. If it is in the case of senior citizens, whether the person will buy a computer or not depends on his credit rating. There are some credit ratings out of 1,000 you get a mark. Such sort of rating is there. Here it is actually fair, excellent, poor, fair and excellent, right? Those are the only values given. So if it is a senior citizen and the credit rating is excellent, that is, if he is good, if he's a rich person, is good money with him, then he'll buy a computer. Otherwise, he will not buy. Okay, so from this data, we have to somehow come up with this model. And once this model is available, you can give data about me or some of your own data, and the person who maybe some person who's selling computers, say Logtech in Trivandrum, they want to actually find out who are the people who will actually buy computers, and then maybe give advertisements to them when they have new products and so on. So they can give data about my data or your data and then decide whether we will buy computers or not. Okay. So that is the overall picture about a decision tree model. Now the question is, how do we come up with this decision tree? So we are given data. From the data, we are supposed to come up with a model. So how do we build this decision tree? That is the next question. Okay, so that building a decision tree is called decision tree induction. Okay, so J. Ross Quinlan, a researcher in machine learning, developed a decision tree algorithm called ID3. ID3. Uh, ID3 stands for iterative dichotomizer. So this is the most basic sort of algorithm for building a decision tree. And then later, Quinlan himself came up with another algorithm called C4.5, which is a successor of ID3. And both of them actually use a greedy approach. That is, it does not have backtracking. At the current point in time, what is the best attribute which can be used for classification? So, okay, that is the approach used by ID3 and C4.5. So, decision tree as a constructed in a top-down recursive divide and conquer manner. Okay, so how do we do it? So, this is the algorithm. So, this is the algorithm generate decision tree. So what is the input to this algorithm? We have data B, which is a set of training tuples and their associated class labels. Okay, then you are also given a set of attributes. How do you describe each of the data item? That is a set of using the set of attributes. And finally, we are given an attribute selection method. How do you select which one of the attributes is the best? So that one thing also has to be decided. So it is a procedure to determine the splitting criterion that best partitions the data tuples into individual classes. So this criterion consists splitting attribute and possibly either speak one. Okay, whatever. This attribute selection method is a method for deciding which among these attributes in the attribute list is the best for the for partitioning or dividing. That is, which one is the best for partitioning at each of the points. So at the first point, which among age, income, student, and credit rating. So which is the best attribute to partition this so that you get the best model. So that is what you have to decide. That is what we mean by attribute selection method. So what is done and output is of course a decision tree. And the method what we do is first start with we create a node n. Okay. Now if tuples in D are all of the same class, that is given D, so we are given D, right? So D is a set of tuples. If all of them belong to the same class means there is no need for further division. Okay. Then what we do is we put all of the elements into the node n. Return node n as leaf node labeled with the class C. Okay. All of them belong to the same class. Now nothing needs to be done. In alternate cases, okay, all of them do not belong to the same class, but if attribute list is empty, that is, we have already considered all the attributes and it is empty, then you have no more attributes to divide. So what you do is all those elements you have in D that is placed in the leaf node n, and you label n with a majority class in D. So D is a set of data items like this. Okay, our data items look like this, and the classes are also given here. So if all the attributes have been processed, you look at which is the class which has maximum number of elements here. Okay, then you put that into that class. Those are stopping conditions actually. But before that, actually, what we do is apply attribute selection method. Okay, so attribute selection method is there are different methods for attribute selection. We look at one of them and then come back to the algorithm. Okay, attribute selection method is a heuristic for selecting the splitting criterion that best separates a given partition D. Okay, so we have to find among the different attributes which one is the best, which we use currently to split our data set so that we come up with the best sort of division. Okay, so information gain, gain ratio, and Gini index are three different attribute selection measures. So first we will look at information gain. Okay, so ID3, our algorithm, our basic algorithm for generating a decision trees ID3, and it uses information gain. Okay, and it is actually it is based on information theory. Information theory is proposed, the pioneer work was done by Claude Shannon. You must have come across Shannon's theorem also. So it is based on information theory. This information gain is based on information theory. Okay, and in that, what you do is you actually find the expected information in a particular data set D. Okay, so we said data set D consists of lots of data items, right? This is an example of a data set. Now, our information gain or information content of a particular data set can also be represented, or we can also say from a different perspective, it represents the entropy of the data set. So what is entropy? Entropy we must have come across in chemistry also, that is entropy of a gas, right? The degree of randomness associated with the data set is called entropy. Okay, so that is what we are encoding here. Okay, the expected information of a particular data set, or the same you can say is entropy also. And entropy of a data set is the amount of randomness in that particular data set. So basically what we want is we want all the classes in our data to be uniform. That is, if you're going to classify using decision trees, we said at the leaf node we will have different classes, right? That is whether a person will buy a computer. If it is yes, okay, yes, this is a class which contains only individuals who will buy a computer, right? Okay, so in this class you do not have those with no values, which means you have a uniform data set. So the entropy is minimum. Okay, so basically that is what we want. We want to split our data set so that the entropy can be reduced. Initially, our entropy means we have a very varied data set like this, where the different items can belong to different classes. But we want to reduce it so that at the leaf node, all of them have minimum entropy. All are uniform. That is what we want. And so that is why we look at this information gain. This formula actually stands for entropy. Okay, entropy of a particular data set. So what is it? It is the expected information. So expected, any time we talk about expectation or expected value, what we say is it is actually an average or a weighted average. So basically here also you have a weighted average value, that is the probability of pi into log pi. Probability of pi is, if you look at a particular data set, what is the probability of those who uh, want to buy computer and those who do not want to buy computer? Those are the two classes which we have. So what is the probability of people who want to buy computer into log pi? Why we are taking log is because always information is represented in terms of bits. So when you say log pi, that actually represents the number of bits which is needed for representing information. So here in our example, what is PI? What is the probability of those who do not want to buy a computer? So how many no's are there? One, two, three, four, five. Five no's. 5 out of 14 is the probability of those who will not buy computer, and remaining 9 out of 14 are those who will buy a computer. So it is from that we compute this particular entropy value. Okay, so minus, there are here m classes, so instead of that, in our example there are only two classes. So we have minus 5 by 14 into log 5 by 14 minus 9 by 14 into log 9 by 14. That is the entropy for the original data set. Okay, that we compute initially. Then what we do is, now suppose we partition the tuples. So we said there are many attributes, right? So in the initial data set, here this is our original data set. The entropy of this data set we have already found. And then what we do is, there are multiple attributes and we can do a partition. That is, at the top of the tree, we can either go for partitioning based on age or income or student or credit rate, right? So for this particular problem, what will be the most appropriate value? For that, we have to actually try out with all the attributes first. That is, suppose we partition tuples in D on some attribute A, having A has distinct values A1, A2, etc. AV. Split A split D into V partitions, D1, D2, etc. DV. Okay. Now, we would like to like this partitioning to produce an exact classification. So what we do is, for each of these attributes, first we take a attribute A, that might be 8. Next, we might take, what was the other attribute here? We might take income. Income might be the other attribute. So for each one of them, we do a partitioning. Okay, we do a partitioning, and like this, that is, for attribute A, say it might be color. So color we take and you partition into 5 different colors. Now once we partition, which means in each of these we have a set of values. Our original D is being partitioned, right, based on this attribute, and in each one of them we will have people who buy computer and who will not buy computer. So again, in each of these we find the entropy. Okay, then we find that is what info dj actually stands for dj, that is for the jth attribute, or the, sorry, for attribute A, we said we have got V number of partitions because there are V number of values, and for each of them we find, that is, for example, in the case of age, we have youth, middle age, and a senior, right? So we have three classes here. So for each one of them, we find the entropy, and then we do this. That is weighted average of that entropy. That is, dj is the total number of attributes divided in jth class. Not class. It is jth. Say for example, we said in the case of age, we have got three partitions. So one of them, dj is d1, maybe d1 divided by total into entropy of d1 plus d2 divided by total into entropy of d2, and so on. So that is the entropy for after partitioning. And the information gain is, initially we calculated for the original data set, and then here we calculate after partitioning. So what is the difference? That is the information gain. Okay, now for each of the attributes, we find out information gain, and the one attribute which has a maximum information gain is the attribute which we choose. Okay, so here we have an example here. So how information gain is calculated and so on. Okay, we will come back to the algorithm before going to the example. So what we said is apply attribute selection rule. From this, we will come across a best splitting criterion. Now label node n with the splitting criterion. So if we find that age is the best one, you label this node with age. Okay, and then a splitting attribute is discrete valued. In case of That is discrete valued only we are considering here. In the case of ID3, we only consider discrete valued. But in the case of SEEP 4.5, which is an advanced version of this algorithm, we also consider continuous valued numeric attributes also. So if it is a discrete value, then you have to split, right? In the case of age, we have to split. One group has young people, the other has middle-aged and old. So multi-way splits, then you, and also you remove from attribute list. Now you can remove age because it has already been considered. Okay. Now what you do is for each outcome of J or splitting criterion. So ages are splitting criterion for each outcome means for each. That is for young, middle-aged and old. What you do is you group them. Okay, let DJ be the set of data tuples in the satisfying outcome J. J means in our example it might be young. So DJ is for young. Now what do you do? That is basically you're splitting. Okay, so you find out this is the attribute which is best. Then you split our data in the data set D into three groups. Okay, one you have only youth, one you have only middle age, and one you have again only senior. Right. So you have a set of values here. Now what you do is you apply the same process here also. That is in youth, that is young people. Again, you find what is the entropy of the data among youth. Now you have to uh, after that you have to split, right? That is what is the attribute you have split with age. Now what is the next attribute with which you are going to split? That you have to find out again after using entropy. That is initial entropy you find for the whole data set. Then you try out the different attributes. After splitting, what is the entropy? So the difference between the two is the gain, and which attribute has a maximum gain you use as a the splitting criterion, and then you keep dividing until you reach what all the elements has the same class. That is our stopping condition. We said that is if tuples in D are all of the same class, then you stop, or if attribute list is empty, we stop. Okay, so this is the process of uh, what do you say, uh, decision tree induction using ID3 algorithm. Okay, maybe we will look at the example in class. Okay, so we'll stop here.